So I'm here to explain how HSBC are leveraging Aeron to solve some problems they had in the electronic trading stack. But to explain what the problem was, we need to go a little bit back in time. 2010, I joined HSBC Cash Equities as an algo developer, and there was very much a culture of buy, not build. OMS, smart order router, algo platform, all vendor. And it became very clear very soon that the algo platform was not deemed for future use. So we started looking around at what we could do about this, and we became aware that equity derivatives were going to stand up a project called the Falcon project. And they were going to build a trading system from scratch that was going to trade futures, equities, and provide an algo container. So we agreed to partner, and I was lucky enough to join that team. And we built Falcon. So by 2014, the first version of Falcon was shipped. And by 2015, we built the algo container in its first version with its first algo. And it's fair to say this was a huge success. We changed the narrative around buy versus build. It became a flagship project for HSBC, still 350 active committers, and there was multi-asset class adoption. So, return back to my old team. We migrated all the algos to the new algo container. Everything was good. But by 2020, we identified the EMS component as a bottleneck for future growth. It had a low and non-deterministic throughput under load. So what is the EMS? EMS stands for Electronic Management System. It's a man in the middle. It's a routing system. Algo orders come into the EMS, routes them to the algo container. Algo container wants to send to the market, routes them to the EMS, and that routes them to the appropriate market. Everything relied on this. So if you can't rely on the latency and the throughput under load, there are certain points in time in an algo that will kill you. As an example, when you get towards the closing auction, all of the algos are trying to do very similar things. They're trying to pull out of the market or aggress to get things done before piling into the close. And then a few seconds before the closing auction ends, everyone is trying to react to the last sort of signals. So the EMS being performant and being trustworthy was critical, and it was becoming a real problem. So quick deep dive into what the EMS was and what the pain points were. At the heart of it, it was pretty well designed. We'd used the disruptor pattern, which is literally a high-performant, mechanically sympathetic buffer between publishing and subscription threads. And we basically, the subscribers, they would sequence the orders as they came in. What we mean by that is put an order ID onto the message. We would then journal it, write it to a journal file for replay. We'd replicate it. One EMS primary, 3 backups, replicate to those guys. We'd unmarshal it and pass it on to the business logic handler. All this had to do was validate the order and make a routing decision, stamp on a routing ID, pass it to the disruptor out, and this guy here would look at the ID and pass it on to the appropriate channel, futures trading, equities trading, algo trading. So at the heart of it, it looked okay. So why did we have problems? Some of the problems around too much garbage. As an example, this is all in one process, but we'd lost control of these guys here. We had a fix engine, a fix library, and 10 years ago, they just leaked garbage. And then on the equity side, we had a vendor API, leaked garbage again. And so garbage obviously means GC, and GC impairs your performance. And then next up, as the project became successful, we started getting more asset classes piling logic into the business logic handler and using inefficient language features. This was all written in Scala. Scala has some great features. You start using them, they create a lot of garbage. So we started being architects of our own disaster, so to speak. But the main problem we had, this guy was the provider of order state. And what we mean by this is, if an EMS went down and came back up, it would come to this guy and say, give me the state of the world. It would come into the disruptor. This guy here would package up all the order state, send it across the wire. The original project, we had like 7,000 orders a day. once we got to algorithmic trading, hundreds of thousands of orders in a complex hierarchy, once you start packing up that order state and trying to send it over the wire, that was a big message. And then we started having big GCs. So we had to pile into the code. We had to sort of really deal with that and break up the messages as they were going over the wire. But you start to get the idea there's red flags. So that was the provider of order state. And then automatic failover. We were really ambitious. We said, day one, we're going to fail over automatically. We had 𝗔𝗂𝗏𝗄𝗵 doing the negotiation. But if you think about all those issues that I've described, you put this system under enough duress, it will fool 𝗔𝗂𝗏𝗏 into thinking primary is down because you're starving threads. And that's what we had occasionally, and that was a problem. And then finally, we had no ability to scale horizontally. We could have got out of this. We had one primary EMS, 3 backups, and we couldn't shard them. So we made a decision. We would take the bits we liked and we would remediate the bits we hated. And we came up with basically a sequencer-based architecture. At the heart of this is a command bus, event bus, and sequencer. If a component wants to talk to one another, they would send a message up to the command bus. It would be consumed by the primary sequencer. It would sequence, it would journal, it would replicate the things we liked. And then it would pass it onto the event bus, and then the components would consume that. So that bit we was okay with. But the bit we really cared about was divorcing the sequencer from the responsibility of replaying state. So we came up with the idea of a replay server. And the idea of this is if the algo engine went down, we'd have a point-to-point conversation with the replay server and then cut back over to the live stream when called up. So that's kind of at the heart of the design. How did Aeron help here? So we got one of our developers sat here to have a look at some products. What could we use for transport? We needed to send messages, right? So what could we use? And we looked around and we liked Aeron Transport, Aeron Media Driver. We found it was very sympathetic to the design that we wanted, like a sequencer-based design, a lot of components, single-threaded, just polling in your duty cycle. And so basically at the heart of this, you have publishers and subscribers. And when you publish, you call into the API and it literally just writes to a log buffer, which is a memory map file. The media driver takes care of all the hard bits, marshalling the message over the network, UDP multicast we use. And then it deals with all the problems with out of order messages using high watermarking. And then at the end of that, that comes out of the media driver to a subscriber. Again, the subscriber's just polling, saying, give me more work. So it was very, very sort of sympathetic to what we wanted to do. And we'd also used it before. And so we were confident we'd used it on another project. It was performant and it was reliable. So tried and trusted wins every time. The next bit kind of broke a few developers' hearts. They were all keen to do the replay server. Who wouldn't be, right? It's a nice bit of coding. But our developer found out that Aeron had already solved it. They basically, quite elegantly, via composition, allow you to sort of add Aeron archive. And so instead of an Aeron media driver, you've got an archive in media driver. So when you're publishing, it goes through the Aeron archive to a file system. And then when people want to replay it from the start of day, a file, they would go to Aeron archive, or they could go to any position in that file. And then they had the concept of replay merge. So once you were back on board, replay back to the live stream. So that saved us months and months of development time. All the edge cases, corner cases, done. And then next, we made a mistake. We decided we would handle replication. How hard could it be? Sequencer goes to the passives write to their archive files. But we started to have a few difficulties with getting things to replay off of the secondary archives. We started speaking to Todd and Martin, and we could have solved it. But then one of our guys said, is there on replication? Let's just try it. And we basically agreed a 2-week sprint, do a POC, and it was a success. And then we rolled it out within the next 2 sprints, job done. And then finally, we're really keen on this concept here in green, the little order state library boxes. We wanted this idea of components to be able to have a consistent state of the orders. And so the idea would be when the messages come off the bus through the transport layer, they go into the library before hitting the application layer. So they've got the state of the world. And obviously this needed to be performant, had to be GC free. And so we have used quite extensively Aeron. Aeron's a high performance set of libraries. And I've highlighted the ones, I scanned the code, and they're the ones that we already use. So again, this is all used in the Aeron media driver. They're all tried and trusted. And when you're building systems, you need to be able to trust things. So how have we used this? So the original problem space was algorithmic. We wanted to replace the EMS with Hawk in the algo space. But anyone that's working investment banking knows that things change and priorities change. And in our case, we had an urgent need to solve a problem in Asia. The Asia markets are quite strict with some of their rules. And the one that kind of really caused us a problem was they wanted aggregated rules. And what we mean by that is they didn't just want the algo flow to be have the rules applied to them. They wanted non-algo flow. And in our current architecture, we were nowhere near that. We had the EMS here, and we had the non-algo flow all the way over here. And to sort of like put them all through one rule was almost impossible. So we just sideswiped it. We put in Hawk in Asia. And we always had to create the vendor market gateway for the hawkification of the algo container. But all we did on top of that, we created a rules library and a rules publisher. And we already had the rules in a system internally called 𝗀𝗂𝗃. So we just took them, published them on the bus up into the library. And then all we had to do was take off fixing components that we sort of wrote as part of core Hawk. And we stood them up, two, one for algos, one for non-algos. So we basically completely sideswiped all of the problems with the complex architecture, routed the flow through to here. And this was a massive, massive win for the business. And then next in New York, they have a vendor smart order router. The markets in America are very fragmented, and you need a smart order router to trade them properly to get best X. The business decided they didn't like the one we had and they wanted to swap it out. So it would have been a nightmare in the complex architecture that we had. So again, we just sort of sideswiped it. We stood up another Hawk instance in very much the same way. We created one fix out component to talk to the new vendor, and then two fix-in components again. And all we had to do then was just redirect the flow slowly but surely over time. So that's the next thing we solved. In terms of what we need to do next, we need to go back to what we started. We were going to replace the EMS for the algo container. So we need to go back to doing that now. India is a growth market for us, and we intend to deploy Hawk and Talon, the algo container, onshore in India, first half of next year. And then finally, we've already got our other sites. We've got algo containers in EMEA, US, and Asia, and we need to hawkify them all. And then finally, we're starting to gather interest from other asset classes, because if you sort of imagine what I'd sort of shown you there, it's not a trading system, it's a set of building blocks. And people are coming to us saying, well, can you solve this business problem? And the answer is always yes. It's like, yeah, you just need to write the Hawk-enabled application with your business logic, and then you've got all the communications, it's all there, the replay's there. So I expect next year, we'll be spending a lot of time with asset classes, helping them stand up Hawk and sort of building out their businesses. Lessons learned, don't fear vendor libraries. As Martin said, it's a scalpel, not a Swiss Army knife. We kind of were all a little bit jaded from using other libraries where you pull in one feature, then you pull in the next, and you have to pull in the next. And suddenly you have all these threads that are out of control, and you're like, oh my God, none of that with Aeron. It's very sort of, very low touch. And then I would just say, finally, if you're serious consider investing in the Aeron support model. We did it from day one. What we get from that, as well as if you go the gold, gold route, you get a really nice feature that Martin's already mentioned. But when we have problems, we send an email that reply and quickly. And if we get bogged down, we sort of keep having this email traffic. It's like, they basically say, God, let's get on a call, guys. And we get on a call and we solve it. And it's really sort of sped up what we needed to do. And that's pretty much it, really. Thank you very much for your time.